Star Trek, if the Enterprise needed to talk to Starfleet Command, they could just send a quick message or have a conversation in real time, even if they were light years away from each other. But like most things in Star Trek, that's not how it works in real life. For one thing, the waves that carry messages can only travel as fast as the speed of light, or about 300 million meters per second. And that may sound really fast, but space is also really big. And as a spacecraft gets farther away, it becomes harder for us to detect its signal. So we need bigger and bigger detectors. Since we're still focusing on exploring our own star system, that's not a big deal right now. If we ever send a probe to another star, though, we'd need a detector the size of a city to get any data from it. But scientists are already working on a solution for that, and it might involve using the sun as a giant lens to strengthen the signal. When you think of a lens, you might think of a curved piece of glass that can magnify objects, like a telescope. But the sun actually creates a lens of its own, called a gravitational lens, because huge objects like stars have so much gravity that they warp and curve space around them. Isn't that just the coolest thing in the universe? When those stars curve space, any radiation traveling toward them, like the light from a distant galaxy, gets curved too. The star bends the light around itself like a giant lens. And if you looked at the star from a distance, you would see a magnified, distorted ring of light around it. It sounds kind of complicated because it is, but gravitational lenses are super useful because they allow us to see distant objects that would normally be blocked by big stars or clusters of galaxies. And because gravitational lenses bend any kind of radiation, not just visible light, they could also be used to magnify radio waves or other communication signals. If a spacecraft around another star shot a message right at our sun, the sun's gravitational lens would magnify and boost the signal so that we could pick it up. It wouldn't speed up the message because the signal would already be traveling at the speed of light, but it would make it stronger so we could send more data and detect it more easily. We have a whole lot of work to do before we're ready for that, though. The main problem is that we wouldn't be able to just use a big receiving dish on Earth like we do with missions today. Like other lenses, the lens created by the sun has a focal point, a place where all the waves of radiation come together. The sun actually has a bunch of focal points, or a focal line, but the closest place to pick up a signal is over 80 billion kilometers away, more than 550 times the distance from Earth to the sun. Compare that to the Voyager 1 probe, which is about 21 billion kilometers away. That's the farthest we've ever sent anything into space, and it took 40 years to get there. And if we're using the sun for long-distance communication, it might actually be even better to go farther than 80 billion kilometers, because that would help us avoid solar flares and other interference from the sun that could scramble communication signals. On the other hand, if we're at the point where we're able to send missions all the way to other stars, maybe getting to 80 billion kilometers out wouldn't be much of a problem. We would have to figure out how to reconstruct the messages we received, though. The signal would be warped by the sun's gravity, so we'd have to do a lot of math to make sense of the jumbled messages we got. On top of that, we'd only be able to get messages from spacecraft on the exact opposite side of the sun from our receiving probe. And if we wanted to send a message instead of just receiving one, we'd have to get that faraway spacecraft somewhere on the sun's focal line so it could pick up our signal, which is pretty limiting when you're trying to explore strange new worlds. So we have our work cut out for us, but some astronomers think it could definitely happen, and that one day we might have a huge interstellar communications network using gravitational lenses across the galaxy. Astronomers can't help but dream big, but even if we never figure out how to visit other stars, we could at least use the sun's gravitational lens as a big telescope. Instead of translating messages and getting the probes in the right spots, we could just use the lens to get a close-up view of whatever is directly behind the sun, like exoplanets or distant galaxies. It would be like having a telescope with a lens more than 1 million kilometers across. But either way, we're definitely not ready to use the sun as a gravitational lens for anything yet, let alone interstellar Snapchat. Thanks for watching this episode of SciShow Space, brought to you by our awesome patrons on Patreon who make everything at SciShow possible. If you'd like to help us keep explaining ideas like this, you can go to patreon.com/scishow. And for more episodes about the universe and the sun, which makes everything we do possible also, you can go to youtube.com/scishowspace and subscribe.